Hello, welcome to the SQLRx Healthcheck demonstration. My name is Lori Brown. I am the SQLRx Practice Manager. Just to give you a little bit of background on me, I've been working with SQL and the DBA for over 20 years. And I have experience from really small shops with one SQL Server instance and one or two databases to large Fortune 100 shops, highly available systems, very complex systems running from mini servers, good old traditional clusters on up to high availability, early versions of SQL, all the way up to the newest versions of SQL right now is 2016. I have spoken for several SQL Saturdays. I've written for SQL Server Magazine and SQL Server Central. So if you're out there online, look me up. I'm all over the place. So we offer at SQLRx to our prospective and actually current clients what is known as a health check. And what that is a live review of current SQL in Windows performance. We do this while working with somebody on your staff. We'll look at your system. We don't need any direct access. And we'll take a peek around your system, talk about what we see, go over things of note, and we'll explain everything all along the way so that you'll have a good understanding of what's happening on your system. This is all designed just to make sure that your system is healthy. If you're thinking about doing some work with a consulting company, hopefully us, that'll let you know that we know what we're talking about. We understand how a system's supposed to work holistically, because if Windows is not working well, SQL's not working well. So we cover the entire thing, both Windows and SQL. What we do is I go over basically many of the counters that are on the vital sign guide that you see in front of you. And for the hardware, I basically go over your processor, memory, and disk, what I call the big three. And in SQL, we're going to go over your configuration, your maintenance, and your best practices. But the vital sign guide is a document that we freely distribute to people that gives the thresholds of good performance and bad performance for specific perfmon counters. But like I said, the processor, memory, and disk. So in the processors, you want your processor to be busy less than 60% of the time. You want a good amount of memory available for your Windows system. Your disk should be doing reads and writes in less than 20 milliseconds. And for best performance, you're doing reads and writes in less than 10 milliseconds. Your disk shouldn't be super busy. They should be almost idle, because if they're almost idle, that means that most of your requests are being satisfied out of memory, and that's really what you want to have, because the disks are usually the slowest point of any system. You want to have plenty of free space. You want to make sure that your NIC cards are processing data in and out. Data needs to be going out and in. And then for SQL Server memory, you need to make sure that SQL is able to have enough memory to satisfy requests right out of memory, so it's not having to go back to that disk again. Then you want to have at least 300 seconds worth of page life expectancy. That's how long that requests are in memory. If it's less than 300 seconds, that's 5 minutes. You're basically churning through your memory, and there's going to be a lot of probably disk pressure. So we look at these perfmon counters on a high level just to get an idea of how well your system is performing. So let's go through a quick demo of what we would do if I was working with you to take a look at a system. So I've got my system. This is my development system. It's kind of small. And I've got under a little bit of stress right now. And those counters that I told you about, I'm going to take a high-level review at them. What I would do is I would get in with your staff, and I would work with you to get these counters set up. I don't have to have direct access. I could actually walk your staff through how to set these up, and let's take a look at them. So as I go through perfmon, anytime I want to understand best what's going on in a system, is I'm generally going to be looking at the averages of any of these perfmon counters. So we would set up perfmon, and we'll let things go through for a little bit, and then we'll just take a look and see if we see anything of notice. So here I can see that the system, the available megabytes, this is for the server itself. It has over 5 gig of memory available to the server, the operating system itself. That's good. You don't want less than maybe 500 meg, otherwise you're going to have a big problem. Your system's on the verge of collapse. Take a look at the disk. So there's memory. I'm going to take a look at the disk. On my system, I only have one drive. I see systems that have multiple drives, no problem. I'll cover all of them. But I'm going to see how busy your disks are. On this one, my C drive is averaging 97% idle, almost 100% idle, which is great. If it was, the closer that number got to 0, the busier my disk would be. Reads, it is not taking long at all. Matter of fact, I've got super good performance out of my disk. Remember, I want my disk to respond in less than 20 milliseconds. That would be 0.020 here. Writes, the same thing. So I've got pretty good disk performance. The transfer is the entire action of the disk. So it's either the read or the write, but it's everything that has to do with the entire response of the disk. So there's a little bit more to it than just the read or the write. Processor time. So I want to see how busy my processors are, and this one, my processor is only 35% on average busy, so it's running well. And then page life expectancy. So that's that 300-second thing that I spoke about, where I want to have requests stay in the SQL Server buffer cache for more than 300 seconds. And this one, I've got things staying in for 400,000 seconds. So I've got really good hardware performance. If I was working with you and I saw this on your system, I would definitely tell you that this system is basically kind of sitting around doing nothing. So if you were having some issues, I would definitely say it's not due to your hardware. If I did find something that was wrong with your hardware, I would definitely point it out to you. If I, for instance, found that reads were particularly stressful, we could talk about the size of the read. We could talk about the configuration of the disk. There's just a million and one things that could cause that. But we are able to find anything that could cause performance, even down to the hardware. Well, once we walk through all of perfmon, this is perfmon for Performance Manager, I'd ask whoever I'm working with on your staff to open up SQL Server. So we'd get on the Management Studio and take a look around. And once again, I don't have to have access to this, but they do need to be administrators so that we can see things in SQL. And the very first thing I normally do is take a look at the configuration. And basically, we walk through all of the pages for the SQL Server configuration, just looking to see how if there's anything of note, anything that's not in a best practices mode. So I see I have 2 processors here and about 10 gig of memory on the total server. So that tells me I need to check and make sure that SQL Server memory has been capped. And here it has not. This is the classic number from Microsoft. That means kind of infinity. If SQL Server memory is not capped, SQL is kind of a memory hog. It can take up all the memory on the system if you're not careful. I usually would advise people to cap the memory, set the maximum server memory to 1 or 2 gig less than the total server memory. So I would actually advise to set this SQL Server to use a maximum of 8 or 9 gig worth of memory. Check to see that nothing has been set to affinitize the processors. And if you have anything that's not best practices set up on your configuration, it's not that you can't set things that are out of best practices. I generally just would question why, because what I find is a lot of software vendors will set up a SQL Server configuration. It won't be in best practices, and the end client just doesn't have any good reason why, and they wonder why their server's not performing well. Here's another thing that is commonly not set to what I would consider a best practice is the default index fill factor is set to 0 here, which means 100%. So when indexes are created on SQL Server tables, that means that the data page for the index is filled up 100%. So if any changes get made to data that's in the index, then many times it doesn't fit back into the data page, and what will happen is it will cause fragmentation. So a lot of times, if your indexes aren't built with a specific fill factor to them, you can have severe fragmentation almost automatically happen. And we'll advise people to set this to 80 or 90. It all depends on what's best for your server, and we can look at that and determine. Here's another thing that's not set a lot of times is you can set all backups to automatically decompress. That'll save you some size, and it'll actually make your backups a lot faster. And the last thing that I look for in the configuration is I always check to see if anybody has set anything interesting with regards to max degree of parallelism and cost threshold for parallelism. The max degree of parallelism is a setting that tells SQL how many processors it can use if a plan needs to be operated on in parallel. And the cost threshold, and that's the cost spot in the plan where it knows that it's got to execute in parallel. And on this system, I found that someone has set max degree of parallelism 1. Well, I've got 2 processors on my system, but the cost threshold is at 10%. 10%. So anything that's more stressful than 10% in a execution plan is going to get operated on in parallel, and it's going to be basically single threaded. So I always ask why that happens, and a lot of times I find on systems that have a lot of CPU pressure, administrators will go in and set this max degree of parallelism to 1 or 2 or some really small number when you've got a lot of processors. And in all truth, if you have enough bad performance, you can try to limit this, and SQL can still overtake your CPUs if you have really bad code running in there. But so those are some of the things that I'll look for in the configuration. The other thing I'll look for is I'm going to go and check usually the jobs that are available and go through and talk whoever I'm working with and ask them about maintenance and monitoring of your system and what's been done. But like on this system, I can see that full backups are taken. That's great. So we have some index maintenance. That's set up. That's awesome. And oh, this is not so great right here. Someone has left a shrink database maintenance plan in existence, and I would be asking whether or not it's being actually used. I find that there's a lot of places that actually still believe that you should shrink your databases on a regular basis, but that's not such a good thing because it automatically introduces physical fragmentation into your databases that cannot be resolved without the good old disk defrag. So index fragmentation will not fix that kind of fragmentation. So these are some of the things that I would start sounding a little bit of an alarm about. And then one other thing I normally go through and check is to see whether or not TempDB has been set up in a best practices mode. TempDB is used on an order of 3 to 5 times more than any of your user databases, so it's pretty important that you set TempDB up in a optimal manner. And so what's optimal? So TempDB should be broken into multiple data files. If you have one TempDB file, it's not necessarily terrible, but it can actually be run faster, better, if you have more than one data file. And so the rule for TempDB is one data file for each processor. And on this system, Windows thinks it has 2 processors. Awesome. And so we've configured this TempDB to have 2 data files. And the catch is that the data files have to be the same size. Well, in this case, they are the same size, so that's perfect. If I found that you have a 24 processor system and you have one TempDB file, I would be asking them some questions. You should never have more than 8 TempDB files. You don't get any more bang for your buck with more than 8. And in newer versions of SQL, all the TempDB files will automatically grow together. In older version, I believe SQL 2012 and below, the TempDB files might actually grow out of sequence. So you can have 8 TempDB files, and you have one that'll grow a little bit more than the others, and it'll actually cause kind of a bad problem in performance. What does this do when you break your TempDB files up in multiple files? It allows SQL Server to use each file basically in parallel. So I will write to all of the files at one time instead of just using one at a time. So that's how it breaks up work into smaller chunks that way. So that's a quick overview of some of the things that I would look for in doing a health check. So if you notice, I didn't collect any data, so that's why I don't need any special access. I walk through everything with your staff member, and I would review it just like this, just talking to him one-on-one. And I've actually found systems that had bad configuration, and the person on staff just didn't realize it, and we've set that one thing for free, and it has completely helped their system turn around on a dime and have much better performance. So that's one of those things. If you had a software vendor set up your system and you're not real sure whether or not you've got things set up in a best practices mode, I definitely think that the health check is a thing that you need to do. So that's really basically it. Pretty simple. Not too super technical. We'll definitely put things into plain terms, and we would definitely love to hear from you. If you have any questions or would like to schedule a health check with us, please contact us. I've got all of our contact information up here. We are all over the internet. Please look us up on the web, SQLRx.com. We have a really good blog where we post a weekly new and interesting material. We're on Twitter, and we're on Facebook. So hope to hear from you soon. Give us a call, and I'll be happy to schedule a health check and review your system with you. Thank you.